One of the biggest problems in climate science has been figuring out how much the global temperature will go up when you double carbon dioxide. It's called the equilibrium climate sensitivity. We've done a new study which shows that estimates of the climate sensitivity that have been lower are founded on models of the atmosphere that are not consistent with observations. The previous estimates of climate sensitivity were that it would be somewhere between 1.5 degrees and 4 or 5 degrees for a doubling of the atmospheric carbon dioxide concentration, which is something that we think will happen by middle of this century. What we found is that it really has to be above 3 degrees. Anything below that is not consistent with the observations. Anything over 3 or 4 degrees is likely to be quite serious, but we'd be looking at oppressive heat stress in the summertime, difficult agriculture in warm regions, and a host of other impacts. What we see in the observations is that when air picks up water vapor from the ocean surface and rises up, it often only rises a few kilometers before it begins its descent back to the surface. Other times it might go up 10 or 15 kilometers. And those shorter trajectories turn out to be crucial to giving us a higher climate sensitivity because of what they do to pull water vapor away from the surface and cause clouds to dissipate as the climate warms up. In many of the models, this doesn't happen. The air always rises up to 10 or 15 kilometers, and so these models have been predicting a lower climate sensitivity, but we believe they're incorrect. What these shallower overturning circulations do is they pull water vapor away from the part of the atmosphere where clouds form that cool the climate. If these things are strong, and if they do this more in a warmer climate, which all the models agree is what happens, then you lose your low clouds and the Earth absorbs more sunlight. The question for many years has been what's going to happen to the amount of low clouds? Does it decrease when the Earth warms up, or does it stay the same or maybe even increase? And what we found is that it should be decreasing because of this mixing process which pulls water vapor away from the layers where these clouds form and causes there to be fewer of them in the warmer atmosphere. Climate skeptics love to criticize the models and point out how they don't do this right or that right, and of course that they're not perfect. But what we found is actually the mistakes are being made by the models that were predicting less climate warming.